and I mean that in a very large and historic sense. Next. We're familiar with the Industrial Revolution. Once upon a time, in centuries past, everything that people used was made by hand. One click, next. But then the Industrial Revolution changed that, and now virtually everything that people use in the parts of the world where the Industrial Revolution has thoroughly transformed the economy, almost everything is made by machines. The machines are made by machines. And the result has been an enormous multiplication of productivity, an enormous multiplication, a very large factor of increase in the wealth per capita, and a great increase in the range of things that can be made. A revolutionary transformation in human life. Next slide. So, I would also like to make a comparison to the digital revolution. Not very many years ago, when I was young, in fact, most information processing was done by analog means. That's a slide rule there, but vacuum tubes and so on were used to process information. Then came the digital revolution, things like what is shown here, the first pocket calculator. And one more click, of course, the computer, which has replaced almost all of the previous means of information processing and has brought the profound revolutions that we've seen from the internet and so forth. So, next. We've seen, I've just described the Industrial Revolution, which transformed the making of material things, and the digital revolution in the information world. One more click. Putting those together, digital control at the level of atoms in making material objects will be a revolution on a comparable scale. An enormous increase in productivity, an enormous increase in the range of things that can be made. Next, please. So, what can this technology do? Obviously, many things can be made, very transformative, but I would like to give some concrete examples, some specific examples. Here we see a supercomputer of the sort that has been built recently. It weighs tons, it consumes enormous amounts of power, it is enormously expensive. With productive nanosystems, this advanced nanotechnology, one click please, a far greater computer capacity, 1,000 times more computer capacity, could be put into a laptop computer-sized package and run off batteries for a reasonable length of time. Vastly lower cost, power, mass, and so on. This resulting directly from being able to make extremely small, precise components that work with very low energy to make 1 billion processors that would fit inside a laptop package. Next slide. Today, access to space is achieved by means of things like this, which will soon be retired, but spacecraft that are very expensive. They're made of aluminum and have made space travel an exotic, a very unusual and expensive activity. Next slide. With better fabrication, it'll be possible to make materials that are 50 times stronger per unit weight, 50 times stronger than aluminum, and to make those structures precisely so that flaws and defects are very rare, and inexpensively. If one looks at the cost associated with that, it appears that the cost of access to space will be comparable to the cost of air travel today. A revolutionary and radical change which will make space an accessible place for human beings. Turning to other aerospace, to other aerospace applications, the use of similar aluminum structures and wings and so on has made possible weapon systems like this cruise missile and, of course, many, many, many other weapon systems. Next, with back one. Thank you. With an enormous decrease in cost, the cost that can come from processing simple materials into sophisticated structures rapidly using productive nanosystems, the same amount of money would enable the production of 1,000 times the quantity of weapons. So this prospect is one reason why we can expect nations to compete internationally, not only for economic reasons and human reasons, but for military reasons, as always in human history, to achieve great levels of capability in this area as well. Next. Turning to matters that involve saving lives rather than destroying. Today we face many diseases, another click please, including drug-resistant bacteria. This one causes tuberculosis. One more click. Viruses, here the H5N1 influenza virus. And drugs today are becoming increasingly ineffective against these. These organisms are evolving immunity to these drugs and are an increasing threat. With the ability to make structures with atomic precision, very small, precise, inexpensively, it will become possible to make machines at the scale of human cells. Now, this is an artist's conception. It's a rather fanciful, not an engineering design, but the illustration that you see shows the scale on which devices can be made that would be able to sense things in their environment, much as the immune system senses structures and can sense pathogens, that could recognize these and then destroy them in a way that evolution would be unable to prevent. So the prospect there is for very reliable ability to fight bacteria, viruses in the human body. Cancer cells could also be recognized and destroyed selectively. And beyond that, biological processes could be influenced in various ways to encourage the growth of cells where they're needed to heal damaged tissue. Next. There are also applications in the production of food. Today, the production of food is very strongly limited, in part because most of the Earth's land surface is unsuitable for agriculture. Enormous areas